is statistically significant. Let's look at weight. Weight is also statistically significant. Let's look at duration. Duration is not significant, is not statistically significant. Let's look at pause. Pause coefficient is giving us a negative value. So note that, we're still going to come to that. Let's look at the p-value. The p-value is also telling that it is not statistically significant. Let's look at stress. Stress also is not statistically significant. So we have two independent variables not statistically significant here, the stress and duration. But most importantly, this negative value of pause here, let's see how true it's supposed to be. How do we go about that? Let's just quickly have our matrix, our correlation matrix, and see the relationship between each independent variable and the dependent variable. So just as the same way we did, you go to your data analysis, this will come up, you click on correlation, you click OK, then you input your data. So let's have it here. We input all of the data. So, and let's label the first row. So this is the result. I would like to bring the result closer to where I could all right, so let's look at the correlation between these variables. With age and blood pressure, there's a positive correlation. Weight and blood pressure, there's a positive correlation which is very high. Duration, there's a positive correlation but very weak. For pause, it has a positive correlation and it also is a strong one. 0.7 is strong, not very strong but is strong. So let's check, and you could recall when pulse and BP is having a positive correlation of 0.7, it's simply just to let us know that increase in this pulse must be increase in the blood pressure. But see what we have here, this coefficient is negative, so in our model it's suggesting that pulse is actually reducing blood pressure as they increase, but that's not true. So this is when we have a bizarre beta weight. This is a contradiction. It's a contradiction. Positive correlation between pulse and BP, and here the coefficient is giving us negative. This is a contradiction, and if you recall, that's one of the symptoms of multicollinearity. And also look at some of the individual independent variables, such as we have stress, it's not statistically significant. Also look at pulse, is not statistically significant, and also duration. You can see we have just 5 independent variables, and 2 out of the 5 are not statistically significant. 2 out of 5, and here we are having a very large R-square value. So this is something that we need to probe further. So how do we probe further? We'll be interested in conducting variance inflicted factor on each of the independent variables. And if you recall, as we have been told in the slide, for us to get the variance inflicted factor of each of the independent variable, we have to, if we are interested for age, given age first, our age here, we are going to be seeing this age as a y, where we treat weight, body surface area, duration, pulse, and stress. We are going to treat them as our independent variable. So when we do that, the same way we go about the analysis initially, this is what we are going to do. Just click on data analysis, look for regression, click OK. Right now this is going to be treated as Y, and for the X we have the remaining independent variables. So all our things as it were, then we have the new result. So I wonder what we'll be interested in this case is just the R squared. As you can see, the R squared is 0.432723. So that particular